Hi everyone, welcome to our talk. Thank you for being here. We're really excited to be presenting this case for you. My name is Julia. I'm a Principal Developer Relations Engineer at Dash0 as of last week. And I'm here with my partner in Observability Crime, Pedro. Pedro, he's a Principal SRE at CLDF. And CLDF is the legislative chamber in Brazil's capital, Brasília. He's also a Golden Kubestronaut. We're both CNCF ambassadors, very involved in the Kubernetes and cloud-native communities. If you have questions about it, come ask us after. Now, tell me if this sounds familiar. You've got part of your infrastructure running on Kubernetes, containers, Prometheus, OpenTelemetry, and then part of the other part still lives in your data center. You have them running on an SNMP, vendor dashboards, and tools that look like they were designed in Windows XP. And the question we're going to discuss today is, how do we actually connect these two worlds? How do we bridge the gap between on-prem and old school telemetry and modern observability pipelines? So let's start with the elephant in the room, which is the observability divide, the case that was in Pedro's organization. So technically, everything runs in containers. And on one side, you can see the legislative chamber, and then on one side, you've got the infrastructure team, so sysadmins and NOC folks who care about disks, about switches, power, and all the physical things that keeps lights on. And then their world is all about stability, keeping workloads up, and keeping all the lights green. Now, on the other side, we have SREs and platform engineers. They're running everything on Kubernetes, again, Prometheus, OpenTelemetry, defining SLIs, SLOs, and they're trying to make everything observable from top down. So both sides, they're doing critical work, which is very important. They depend on each other, but they're living two completely different realities. And when something breaks, they don't talk to each other. They don't have visibility into each other's layers. And they started this scientific troubleshooting process that we call blaming the other team. So now let's break down why that happens. The first challenge is fragmented telemetry formats. So Pedro's setup is the perfect example. Everything runs in containers, but the data that they emit depends entirely on where they live. So in the data center, the monitoring stack still speaks ancient dialect. SNMP, traps, the vCenter, APIs, Syslogs, etc. Everything, they have their own schema, timestamps, and naming convention. But the other side, the cloud side, speaks fluent PromQL, OLTP, TLP, and you've got structured JSON logs, etc. So everything in paper is telemetry, but in practice, it's like comparing Celsius to Fahrenheit, which is really hard. So when you try to correlate the data, you spend more time translating and normalizing than actually analyzing that. So, and if you've ever been in the middle of an incident, you know how costly that is. Now, the second challenge is there is no shared context. Imagine you get an alert. There is a high spike on the CPU in a node. Great, you have that information, but why? Where that comes from? Is that from a bad deployment? Is that from a memory leak, a traffic surge? We don't know, and that's the problem when the metric exists in isolation. You have information, but you don't have the story behind it. So the problem isn't that the data isn't there, it's just there is no connective tissue around the whole data. And traditional monitoring tools, they were never built to really understand the logic from entities like pods and namespaces. They see the hardware, but not the workloads. And on the other hand, the cloud tools, they see the workloads, but not the physical reality underneath. And that's what we mean by missing context. Okay, so even if we normalize the data and we build some kind of context between systems, that's good, but if you zoom out, you realize that you've actually built 5 different observability stacks. And this is what we call tool sprawl. And each tool, they have different data stores, access models, authentication, alerting rules, etc., etc. So instead of one source of truth, you have 5 now. And that's when you realize that observability doesn't fail because there is data missing. It fails because the story is actually fragmented across 5 different tools. And integrating that, it's a whole full-time job. And the irony is that we built these tools to gain visibility, but somehow we made it harder to see. Now, finally, the last challenge is there is no common language for observability. And the term observability means different things for different people. For instance, for DevOps people, they talk about golden signs. For for sysadmins, they talk about uptime, they talk about bandwidth and alerts. For the leadership, they will say and ask you, why are we paying for 3 different tools? So it's different for each one, and everyone's measuring something, and it's not the same thing for the whole company. They don't share the same conventions. And even if you push all the telemetry data in the same database, you still end up with different things. So it's really hard, and it's a standardization problem. And that's where OpenTelemetry comes in. So it standardizes everything for us, because it doesn't care where the data comes from, only that everyone agrees how it is described. Now, if you look at the CNCF activity, this is from, I think, the beginning of the year or last year. OpenTelemetry sits second right after Kubernetes. And that's not a coincidence. This is because it has become the universal language for observability. OpenTelemetry describes one consistent way to collect, process, and export telemetry from anywhere. So whether from the data center or the cloud, if we're running on the cloud. And OpenTelemetry doesn't care what tool you use downstream. It just ensures that the data is portable, consistent, and vendor neutral. Now, finally, 2 secrets I want to tell you before we talk about the real case. The first one is that tools are easy, but culture is hard. And the second secret is that the real integration isn't code, it's actually communication. So, because even if you build the perfect pipeline, observability won't work if your teams don't communicate, if they don't collaborate together. And that's where the DevOps and SRE's culture come in. So the DevOps one, they gave us the idea of shared ownership, breaking the wall between dev and ops. And then SREs, they made that concrete. They are putting reliability right at the center of the problem. And observability is how we make that collaboration visible. It's the shared language between people who build systems and people who run them. Okay, great. So now finally, the question is, how do we build all that in practice? How do we make these ideas like open standards, shared culture, and consistent telemetry run together in production? And that's exactly what Pedro built at the Legislative Chamber. He designed an open source framework using OpenTelemetry and other CNCF tools and open source tools as well. And it starts with the OpenTelemetry Collector, and that sits right in the middle of it all. It's extended with contrib receivers for vCenter, SNMP, and other traditional interfaces. Then you have semantic conventions. So every signal, logs, traces, metrics, they get normalized with that. And finally, from there, the data fans out from a unified open pipeline. We have Prometheus for metrics and alerting, OpenSearch for logs and long-term queries, and then we have Perses for open dashboards that anyone can use. And with that, I'll pass it to Pedro, who is going to talk to us a little bit more about that.
Thank you very much, Julia, for the introduction on the team. Actually, we have to consider that telemetry itself is not an end. Telemetry serves us in order to understand what is happening in the interface for our end user. And when something is not happening as desired, we have to understand the story behind it to see where action must be taken. In that way, in our case, in our scenario, which we know is not, we are not the only ones in this scenario, we are running containerized applications on top of Kubernetes, mostly on top of on-premises environment, where we are responsible in different teams, of course, by different layers of abstraction, ever since the physical hardware up to the container of applications that are serving our end user at the end. So in that case, it seems not to make too much sense if I have just one team who is observing signals, metrics, and logs from infrastructure components, and these are totally air-gapped from what is happening on the top layers, because they might be looking at some symptoms that might not be affecting end users, for example, and investing their money, their resources, their time into solving problems that do not exist actually. Or either the opposite. We might have people deviating attention when we are not properly correlating what is happening in those different layers of abstraction. And that's why we saw the need to integrate these worlds. OpenTelemetry for us was a groundbreaking tool and project, mainly because, as I think many of you have heard, because many people say that the semantic conventions are the very core of the value proposed by OpenTelemetry, because the semantic conventions are a way to create a unified approach that is independent from the specific solution, either open source or enterprise version that you are using to store your telemetry, to collect it, to analyze it, and everything so. So what if we could also apply those semantic conventions in a way to spread the context among not only the cloud-native layer of abstraction, but also for our data center layer. So in that case, we proposed an architecture, and this is all this content is based especially in an article that we are going to share a QR code at the end of the presentation with you, where you can read further details. But anyway, feel free to contact us about that. But we are here presenting a brief overview of this architecture, of this framework we are proposing. And this framework here is totally based on open source projects, even though these boxes might be interchangeable for other either open source or enterprise solutions, depending on the needs specific to each corporation. So our approach starts with the collection of the data from our data center. And this collection of data, especially talking about metrics and logs, are based on some of those protocols that Julia mentioned that are the main dialects of that world, which are mainly SNMP, Syslog. These are the most common ones for metrics and logs respectively. But also, we are also using Redfish because it is a little more self-described than SNMP for some metrics that some of our hardware delivers, such as our Dell iDRACs, which are the controllers of our physical service. Then we bring those data into the OpenTelemetry collectors, and then this becomes part of a unified pipeline where the data from the cloud native layer comes together and are brought together to the backends that are storing those metrics, those logs, and finally with our dashboards that are looking at everything in a completely unified view. But the focus here is more about the left-hand side of the architecture more than the right-hand side, because the right-hand side is what I think most of you are already used to. In this sense, going into further details, we've seen that we've used the Telegraf Collector in order to gather data from Redfish API. That is just because the Redfish receiver on the OpenTelemetry Collector were at that moment at least not mature enough to eliminate the need for another component. Also, because SNMP receivers on the OpenTelemetry Collector contrib at that moment was not feature-rich enough to attend our scenario, we also made use of the SNMP exporter and then passed those metrics by scraping from a Prometheus receiver inside the OpenTelemetry Collector and then bringing them all together in the pipeline. And also in the OpenTelemetry Collector, we are using some processors in order to make the transformation in the data to make any necessary adequations in order to get those data totally inside the semantic conventions. Well, but that was not enough for our production scenarios because in our case, and we understand that especially in corporations that are a little bit larger than the average size and that has many data, we needed to create some buffer because we had some spikes in the volumes of those telemetry data. When you bring data from data centers, especially logs, and especially when dealing with logs from things like firewalls and all that, UDM, we are talking about a large amount of data. And because of that, we created another architecture with one more component, which was Apache Kafka for creating a layer of resilience, both for not losing data, but also to create a layer where the spikes would be handled seamlessly without affecting other components. Also, the Kafka, by creating an integration layer, allowed us to segregate an infrastructure dedicated to observability from the Kafka to the right and not affecting the, let's say, the production systems infrastructure and causing less risks for our production system. So in that case, this is the drawing here the plot of our architecture. So we have a first layer of collector, and then we go through the Apache Kafka, and then the other layer of collector, and then delivering those data to the backends, which are going to store them. And then we have a little more detail on this architecture, and showing us that we are dealing with logs and metrics in separate topics and in separate pipeline, but using the same components. Here we are not talking yet about traces, because by bringing logs and metrics from the data center, we saw as a great deliverer of value, and traces is something that we are planning to do in a later moment. Firstly, we are trying to mature this approach with logs and metrics. And another need that we found was about long-term retaining logs, because in data center, our team was more used to the need of logs that need very, very long retention, especially those logs that are related to audit, security logs. For example, logs from the UDM, from the firewalls, logs from our Active Directory, and all those. And because of that, we saw that storing those logs in the same backends that were storing system logs and low retention logs would be very costly, because even when talking about the open source backends, such as OpenSearch, there is a great need for infrastructure resources to store those logs. And because of that, we created a fan-out in our pipeline for those logs that need a longer retention. And this fan-out thus creates a secondary path from Kafka to create Parquet files by using Apache Flink and doing the time window from Apache Flink, which is a wonderful feature from that project, also open source. And Flink creates a possibility of closing one file for one specific time window. It can be 1 hour, 1 day, depending on the needs for all the specific implementations. But the Parquet files, which are our output, and they are stored in S3 in this case, they are files that are stored in a columnar format. They are also indexed by some columns, so they are queryable without having to read the entire file. And also they support natively compression. So by using Parquet files with ZSTD, which were our decision after doing some benchmarks, we could compress a lot those files and have a very cheap retention storage cost for those logs by using very cold tiers in S3. So this is a little more detailed plot of such architecture, showing us that we can handle seamlessly the two pipelines for logs that are originating here from the same log topics in Kafka, using different backends. So in this case, as we talked, we are using lots of receivers from the OpenTelemetry Collector contrib. We don't have to reinvent the wheel, so whenever possible, we are using the existing receivers. And mainly, for example, the vCenter receiver helps us a lot. Also, we are using, as said, the SNMP exporter as a point of entrance from the metrics that are then scraped from that exporter to the OpenTelemetry Collector, and using Telegraf to get data from Redfish APIs. These are especially useful, for example, to get temperature and fan rotations per minute from our service. And at the end of the day, OpenTelemetry helps us a lot with several features, such as doing the pipeline, transporting those telemetry signals, but most of all for using the semantic conventions to use the same way attributes are located regardless of where the data is originating from. By doing that, for example, I can correlate that a certain workload that is running on top of a container is actually running on top of a certain physical server, and I can see through all the layers of abstraction and of virtualization how is the health of that exact infrastructure components. And I can verify that in some moments, for example, my physical infrastructure is perhaps the cause, the root cause, why my workload is failing. So, in the end of the day, what I'm able to do is understand how my telemetry from a data center is correlated to my end user experience. Because my end user experience is not measured by percentage of CPU usage. It is measured rather by availability for the end user, for latency for the end user, for these signals that are sensitive for the end user. And that's the real way to generate value from telemetry, from data center, in a way that we are putting those together with what the end user suffers from. And then we are using, in this case, Prometheus and OpenSearch as backends. Remember, as I told you, this is the backends here are not the focus, and they are interchangeable as much as your company needs demand so. So you can, for example, use -0, which seems to be a great solution to help us with all those telemetry signals. But we have plenty of great solutions. You know that, both open source and enterprise. The idea with OpenTelemetry is to empower us to really own our telemetry data regardless of which solution we are using. Then we have some key benefits. As I just told you, data ownership is the first benefit, because I can plug whichever backend solution I want, and I can change the backend solution I'm using at any moment. And this empowers the organization. I avoid vendor lock-in. I do cost reduction because I can, for example, use a multitude of more than one backends according to the needs for any business unit or any environment I have. I can use an open source for staging environment, meanwhile an enterprise solution for production environment, for example, and use a unified analysis. This is the QR code for the article that is all this content that we've shown here in this presentation. Feel free to scan the QR code. It is an article in Medium, which was published some months ago. It is exactly this, and it gives more context than the time would allow us in this talk to give. Yeah. I'm bringing back Julia to do the closing remarks.
Yeah, I think everyone scanned it. And now we just wanted to thank you. The real value of this was all about this use case. And if you want to learn more about, OpenTelemetry or about this case, feel free to connect with us. The QR codes are there for our LinkedIns, and we're going to be here throughout the next few days. You're going to see me wearing this red suit, and we thank you for coming.
Thank you very much.
And if you have any questions, I think we have 2 more minutes. Yeah.
Yeah, in the time we have left,
yes.
Please feel free for questions and answers.
Can you ask over there, please?
It's necessary to use the microphone.
Yeah. Just probably for the recording.
Yeah.
All right. Thank you for the talk. It was really informative.
Thank you.
I have a quick question on the buffering in the face of Kafka when you introduced it. What was your approach on deciding the partitioning strategy? And did you encounter any issues with regards to message ordering?
Okay. When making the decision on partitioning, we have to take account the specific requirements for that data. So dealing with only one partition, for example, for a topic, guarantees us the order in delivery. If that is necessary, which in our case, it didn't seem necessary for telemetry data, then one partition is a requirement. In our case, in order to better spread our data through the brokers in Apache Kafka and to scale better the solution, we made lots of partitions that were actually in a number that was according to the number of brokers we had in our environment. And we can always rebalance our topics. So actually, we are doing as much partitions as it makes sense to the number of brokers we have in our Kafka cluster.
I see. Thank you.
No problem.
How are you associating nodes with workloads? Like, are you tagging the node output with the SNMP collector, or is it on the workload side that you're associating it?
That's an interesting question. When we get the data from the lower layer, so for example, let's say I get the data from the virtual machine, then I have some attributes, from some resource attributes that identify my virtual machine. At the same time, my data that comes from my Kubernetes pod also has a resource attribute that shows in which node that pod is residing onto. So by making sure that I am using the same convention for the name of the virtual machine that corresponds to that Kubernetes node with the name of the node that is in the resource of the pod, then I can do the correlation. The important thing is to use unified identities for your infrastructure configuration items throughout all the layers of abstraction.
Got it. And then do you have anything associating the nodes with like physical infrastructure above the host, like the routers or anything? Or
I'm sorry, could you please just repeat?
Sure. So you can associate the nodes and the workloads. How are you associating the VMs with the hardware, like the routers above it, or how's that work?
Yeah, this association happens through the data that comes from the hypervisor. In my case, the hypervisor is VMware, so I'm just make sure that the data from the virtual machines also have a resource attribute that identifies the physical host where that virtual machine is running at that moment.
Got it. Okay, thank you.
Thank you.
Yeah, just real quick. Did you find yourself having to develop, I guess, bespoke or custom exporters, to get those data into metrics for Prometheus, or was it all kind of off the shelf, open source, pre-configured?
I could say that it was a little mix of both worlds. I didn't have to develop myself or my team components, but when we used the SNMP exporter, we had some issues because we had to make a very, let's say, a very manual mapping in our data from the OID tables. So we had to bring the tables from that specific component that we were collecting SNMP data from, and then do the mapping to the data that would be inside our exporter. So yes, it required some manual work. It was not a developing-like manual work, but since our environment is mostly comprised of homogeneous components, so for example, we use all the switches from one single vendor, we use all the servers from one single vendor, that helped a lot.
Cool.
Thank you.
Hey, kind of a two-parter. So the first one is the data centers that you're running in. Are these data centers that you said you work for the country of Brazil, or?
Yeah, we are a government institution there in Brazil, and we own our own data center.
Okay.
And we have teams that are responsible for dealing with all the layers since engineering of data center up to all the equipment.
So I guess my follow-up question would be, observability just beyond the hardware that you're running applications on, do you also take in data from environmentals, from PDUs, branch circuits, stuff like that? The actual metrics, like the power and cooling aspect of the data center?
I'm sorry, could you please just?
Sure. So since you guys are in your own data center, which is, I think, probably kind of a unique thing, maybe not unique, but rare, how much of the metrics are you observing beyond just the hardware that you're running your applications on?
Okay. We try to get data from many different layers. Perhaps it is rare when you talk about the very first physical layers to have other use cases similar to ours. But as you go up and up, I would say that are more and more similar use cases from ours. So the idea is that you can, for example, let's say you have a situation that would be like a subscope of this of a situation of ours. Then you could use the same approach only in the layers of abstraction that you are responsible for. So for example, let's suppose that you are hosting bare metal servers by a third provider and you deal with the hypervisor. Then you could do this approach from the hypervisor up. Or let's suppose that you are running a Kubernetes cluster on top of infrastructure as a service inside public cloud providers. Then you could do from the virtual machines up the same approach. The idea is that I am having exactly like a full scope, but the approach is applicable to any subscope of this layering.
Okay. Thank you.
Hi. Do you have advice on how to mitigate data ingress costs for log data in particular going into AWS? Because I imagine it can get expensive pretty quickly.
Yeah, this is a very common pain. I will just end this answer here, even though the time's up. But what I can say very quickly is that you have to understand what is really required for you to gather and to retain. What is really important. For that, there are some specific solutions that help you mapping if you are getting too much or too little data. In the case of telemetry, you can either filter those data in the middle of your pipeline, or you can use like a hybrid approach where you store the data that is most critical in a more, let's say, expensive, but with more guarantees infrastructure or provider, and the other ones in a cheaper solution. But in order to automatically discover that, I would seriously recommend using some tool to give you insights over the telemetry signals, such as OliGarden or some other tool like that.
Cool. Thank you.
Thank you.
Thank you, everyone.